Stan Gibilisco here to show you a typical bandpass response that you'll find in a communications receiver in a sort of a generic form. And here it is. This is the gain versus frequency curve that you will see in a good communications receiver. Relatively steep transitions from maximum gain to minimum gain on either side. They call that steep skirts. The skirt selectivity is how steep this part of the curve is. So what you hear is anything between the frequency f sub 1 and f sub 4, but what you hear best is the stuff between the frequencies f sub 2 and f sub 3. Now for CW communications, that's Morse code in ham radio, a typical value for this band width right here, f3 minus f2, is around 500 hertz, although it can be narrower down to, in some cases, only about 100 hertz, or a little wider, in some cases up to 700 or 800 hertz. For a single sideband, the standard bandwidth of a single sideband signal in ham radio is 2.7 kilohertz. So that would be the ideal difference between f sub 3 and f sub 2, 2700 hertz. Although you can make it a little bit less and get a little bit better selectivity, but the quality of the voice will go down. If you make it wider, the quality of the voice won't get any better, but you'll allow in more interference. This is a band pass response curve that you will find in a typical ham radio receiver. And in modern receivers, these skirts are quite steep. In older ones, they're much less steep. They're much more shallow because they used inductance capacitance circuits to obtain the selectivity. Nowadays, they do it with digital signal processing. So that's just a basic overview of how CW and SSB can be received through a bandpass response or IF filter such as this. Stan Gibilisco is signing off from somewhere in deep space. Anyway, they call it the giant gaseous cavity within star-forming region NGC 3324. And I guess you can find it on hubblesite.org and use it, as I have here, as wallpaper or your desktop background. Ain't that cool? Until next time, so long.